build the rational expression into an equivalent fraction having the given denominator. So we have here one rational expression. It has a denominator r squared plus 6r plus 5. I'd like to change that into a fraction that's the same fraction, equivalent fraction, but has a different denominator, r plus 1 over r minus 4 times r plus 5. We know, of course, that we can do such things. I mean, if we have numbers like a half, we know that that's equivalent to, say, 2/4 or 3/6. Whole slew of different ways that we can write fractions that are equivalent to each other when we're dealing with numbers. Same thing when we have expressions. We can go ahead and write a whole slew of different irrational expressions that are equivalent to this one. Our main tool for changing a fraction into an equivalent fraction is something that on the surface sounds really silly, but it works great. That tool is to take a fraction, say a over b, and we're going to multiply by the number 1. But we're not just going to use, 1 like that. That doesn't do us any good. We're going to use a very special choice of the number 1. We're going to use one that is written as something divided by itself. Right? C over c, that's a fancy way. Well, not that fancy, but it's one way of writing the number 1. And when we do this, this fraction now has a denominator b times c. So we've changed our denominator. We also changed the numerator, right? A times c. This is really the opposite of canceling, right? If we started with this purple thing, a times c over b times c, I could cancel the c's and get a over b. Well, if I want to undo the canceling, I put a common factor in both the numerator and denominator. Okay, so that's what we want to do to rewrite an expression into an equivalent expression. Of course, we want to figure out what c to use. Okay, so to do that, what I'd like to see is what factors r squared plus 6r plus 5 have. If they have some of these already, I don't have to add them in by add them in is the wrong word, multiply them in using this trick. So let's try and factor r squared plus 6r plus 5 real quick. R squared plus 6r plus 5. I'd be looking for two numbers whose product is 5, say 5 and 1, and whose sum is 6. 5 and 1 happen to work. So x plus 5 times x plus 1 is how this denominator factors. And you'll notice our these are not x's, those are r's. Sorry, I'm too used to x's. R plus 5 and r plus 1 happen to be two of the things in what we want to be our new denominator. So all that's missing is this r minus 4. So that's what our c is going to be. So we'll take our original, I'm not writing things correctly. We'll take our original fraction, 9r. I'll go slower, I won't make mistakes. 9r over r squared plus 6r plus 5. And I'm going to go ahead and multiply by r minus 4 in the denominator so that I get to have the denominator that I want. Of course, to multiply by the r minus 4 there, I have to be only multiplying by 1, so I put the r minus 4 in the numerator as well. Here's my big fancy 1, right? The c over c, r minus 4 over r minus 4. So now when I do this product, the factored form of this denominator, right, we figured was r plus 5 times r plus 1, so let's write it that way. Now we also have an r minus 4. In the numerator, 9r times r minus 4. No reason to multiply that through, right, unless it asks us to. We like factored form. And here we have our final answer. We have this rational expression rewritten as an equivalent fraction with a new denominator. Now I want to give you a small warning here. A lot of times when we're doing this, I'll see some people go ahead and they put in the correct things here, this r minus 4 both places, and then they see this, and that's a nice factored form, and they say, oh, hey, look, I have a common factor here and here. Let's go ahead and cancel that. I think because that's what we do when we see common factors. We cancel it. But you got to remember, you're the one that put that common factor here using this trick, right? So we don't want to cancel that. We want to leave it there. That was the whole point of doing this. So be careful when you multiply in something extra. Leave it there for as long as you need it there.